Here are 10 sake stories, Kanto, Chubu edition, you can listen to in English. Now, let's get started. Flower yeast. Can you imagine drinking sake that originated from the nectar of a flower? Raifuku Shuzo, a brewery in Ibaraki Prefecture, achieves this by using flower yeast successfully isolated by the Tokyo University of Agriculture. These unique yeast strains, separated from flowers such as strawberries and climbing roses, are scientifically notable for their ability to produce large quantities of malic acid and ethyl caproate. This specific biochemical process results in sake with a uniquely brilliant and fragrant floral aroma, distinguishing it from conventionally brewed products. At its core, yeast is a microorganism responsible for converting sugar into alcohol during fermentation. Raifuku Shuzo has expanded upon this basic principle by employing a diverse lineup of more than 10 different types of flower yeast, including those from Abelia, Begonia, and Rhododendron. By strategically pairing these yeasts with various sake rice varieties, they are able to brew a wide portfolio of junmai sake, each possessing a distinct aromatic profile. This innovative method represents a remarkable scientific application of microorganisms found in the natural world to create unique beverages. Red yeast sake. Have you ever seen a sake that is naturally pink? At Makino Shuzo in Gunma Prefecture, their Osakazuki Art Deco Junmai Ginjo Rouge achieves its striking pink hue thanks to a special red yeast. This yeast, a unique strain of Saccharomyces cerevisiae, produces a red pigment as it ferments sugar into alcohol. This natural pigment stains the entire fermentation mash, known as moromi, resulting in a beautifully colored final product without the use of any color additives. The influence of this yeast extends beyond its vibrant color to create a distinctive flavor profile. The sake is exceptionally sweet, with a sake meter value of -57, which indicates a high residual sugar content. However, this sweetness is balanced by a refreshing tartness derived from citric acid, another byproduct of the yeast's metabolism. This provides a clear example of how a yeast's specific metabolic pathways can directly determine not only a sake's appearance, but also its complex balance of flavors. Hard water brewing. Did you know that the mineral content of water can completely define a sake's character? At Iwase Brewery in Chiba Prefecture, sake is brewed using super hard water with a mineral hardness exceeding 250 milligrams per liter. This water is rich in minerals, especially magnesium and calcium, which act as vital nutrients for the yeast and koji mold. These minerals aggressively promote microbial growth and accelerate the fermentation process, resulting in a sake with a remarkably sharp, powerful, and crisp flavor profile. This phenomenon is a clear illustration of a traditional concept in the sake world. Generally, soft water, which leads to a slower, gentler fermentation, is said to produce smooth, delicate onazake, or female sake. Conversely, hard water, which fuels a rapid and vigorous fermentation, is known for creating dry, full-bodied otokozake, or male sake. The sake from Iwase Brewery is a perfect chemical embodiment of this principle, demonstrating how a single natural element, water, can dictate the entire style and taste of the final product. Seasonless Sake Brewing. Can a beverage traditionally brewed only in the cold of winter be crafted year-round in the basement of a city building? For Nihon Izumi Shuzo in Gifu Prefecture, the answer is a resounding yes. This innovative brewery operates from an unconventional location, the basement of a building right in front of a train station, and employs a system called Shiki Jozo, or four-season brewing. They achieve this by using state-of-the-art air conditioning to meticulously manage the brewing environment. This technology allows them to control the temperature of the fermentation mash, or moromi, with a precision of 0.1 degrees Celsius. Such precise control optimizes the yeast's activity, enabling them to consistently produce sake with their exact intended quality and flavor profile. This modern technique is a departure from the conventional method of kanzukuri, cold season brewing, which has been the standard for centuries. Traditional brewing relies on the natural low temperatures of winter to inhibit the growth of spoilage microbes and ensure a slow, deliberate fermentation. Nihon Izumi Shuzo, however, leverages scientific technology to artificially replicate these ideal cold conditions regardless of the season outside. By creating a controlled environment, they not only overcome the limitations of the traditional calendar, but also ensure a stable, year-round supply of fresh products like their nigori, cloudy sake. Ancient brewing science. Did you know that some sake breweries rely on invisible airborne bacteria to craft their products? This is the essence of the Kimoto method, a traditional technique dating back to the Edo period, still practiced by breweries like Terada Honke and Tsuchiya Shuzo. Instead of adding pure lactic acid, this process involves meticulously cultivating natural lactic acid bacteria from the brewery's environment within the yeast starter. The lactic acid produced by these bacteria creates an acidic shield, eliminating unwanted wild yeasts and microbes. Crucially, this biological activity also generates a rich profile of amino acids and peptides, which are the direct source of the sake's signature deep, complex, and savory umami flavor. In stark contrast, over 90% of modern sake is produced using the sakujo moto, or fast brewing method. This technique involves adding pure, commercially produced lactic acid directly to the mash, significantly simplifying and accelerating the process. While efficient, it bypasses the intricate microbial interactions of the traditional approach. By intentionally choosing the time-consuming and labor-intensive Kimoto method, brewers are making a scientific choice to leverage microbial diversity. They are essentially converting the complex biochemical activities of a natural ecosystem into the final quality and unique character of their sake. Glutinous rice sake. Did you know that adding a specific type of rice at the very end of the brewing process can create an exceptionally sweet sake? Marusei Shuzoten in Nagano Prefecture achieves this with its Ikioi Masamune sake using a rare method called Mochigome Atsugake Yondan Jikomi. This technique involves adding hot, steamed glutinous rice, mochigome, during the fourth and final stage of fermentation. The science behind this lies in the starch composition of the rice, which is 100% amylopectin. This molecular structure is more easily broken down by saccharification enzymes compared to the starch in regular sake rice. This efficient conversion supplies a final, significant dose of sugar to the fermentation mash, creating a sake with a distinctly rich body and a deep, luscious sweetness. While most sake is made from non-glutinous rice, uruchimai, in a standard 3-stage process, this 4-stage preparation is a specific choice to alter the final flavor. The use of glutinous rice, in particular, is a calculated brewing design to engineer a specific taste profile. By introducing this easily saccharinified starch at the end when yeast activity is slowing, more sugar remains unfermented in the final product. This allows the brewers to precisely control the level of sweetness and body, resulting in a uniquely full-bodied and sweet sake that stands apart from those made with conventional methods. Wild brewery yeast. What if the very air inside a building could be the secret ingredient for brewing world-class sake? At the Senkin Brewery in Tochigi Prefecture, this is precisely the case. While over 90% of sake breweries use commercially prepared pure culture yeasts, such as those from the Brewing Society of Japan, Senkin relies on kuratsuki kobo, or wild yeasts that are naturally resident in their brewery. Instead of a single, selected yeast strain, Senkin sake is fermented by a diverse community of multiple yeast strains that have inhabited the building over generations. This method transforms brewing from the management of a single microorganism into the art of orchestrating an entire ecosystem. The result is a sake with a remarkably complex flavor profile that cannot be replicated anywhere else, as it is a direct expression of the brewery's unique microbiome. This approach is a form of brewing science that leverages the power of a natural, symbiotic community of organisms to create a taste intrinsically tied to its specific place of origin. Abolished pole-mashing. Can a traditional, centuries-old crafting process be improved by simply eliminating a step? This is precisely what happened with the Yamahai method of sake brewing, practiced by breweries like Fuji Takasago Sake Brewery in Shizuoka. This technique is a variation of the older Kimoto method, but omits the physically demanding Yama-oroshi process, which involves mashing steamed rice into a paste using long poles. The elimination was based on the scientific discovery that the enzymes, specifically amylase produced by the koji mold, are sufficient to dissolve the rice and convert its starches into sugar without manual mashing. This insight made the arduous, labor-intensive task redundant. Despite omitting this key step, the Yamahai method retains the core microbial dynamics of its predecessor. Similar to the Kimoto style, it relies on a natural succession of wild microorganisms. First, nitrate-reducing bacteria thrive, followed by lactic acid bacteria, which produce lactic acid, creating an acidic environment that eliminates unwanted microbes. This carefully managed sequence of microbial activity, or succession, cultivates a robust and powerful yeast starter known as shubo. Therefore, the Yamahai technique is not just about labor saving. It is a sophisticated method that rationally applies scientific understanding to harness the power of natural microorganisms. Rapid sake starter. Did you know that a scientific innovation in 1909 managed to halve the time needed for a crucial step in sake brewing? Aichi Prefecture is known as one of the birthplaces of the Sokujo Moto, or rapid starter method. Developed by the National Research Institute of Brewing, this technique involves adding a pure culture of lactic acid directly to the starter mash. This introduction of acid at an early stage swiftly creates an acidic environment that suppresses the growth of unwanted wild yeasts and spoilage bacteria, allowing the pure sake yeast to propagate safely and efficiently. This modern method was a revolution compared to the traditional Kimoto method, which relies on naturally occurring lactic acid bacteria and takes about 30 days. The Sokujomoto method shortens this period to approximately 14 days, enabling stable and predictable brewing. This breakthrough in microorganism management streamlined the entire production process and established the foundation for modern sake brewing. It is a clear example of a scientific victory that optimized a traditional craft for consistency and efficiency. Barrel-aged sake. Have you ever considered what sake aged in a whiskey or wine barrel might taste like? The Shichiken Brewery in Yamanashi Prefecture is exploring this very concept by aging their Japanese sake in used barrels from other spirits. For example, Their Mori no Kanade sake is aged in used white wine barrels made of French oak. This process is not merely for storage, it is a deliberate scientific method to create a new flavor profile. As the sake rests in the barrel, it absorbs various compounds from the wood, such as polyphenols and other aromatic elements. These substances then interact with the sake's original delicate jinjo aroma, which is produced by the yeast during fermentation, resulting in a complex and unique beverage. This innovative technique scientifically constructs a new sensory experience. The barrel aging imparts distinct notes, such as vanillin, a compound that gives a vanilla-like aroma, which elutes from the French oak. Furthermore, the maturation process chemically alters the amino acids within the sake, leading to the formation of new compounds, like solotolin, which can contribute caramel or nutty aromas. This synergistic effect between the barrel's chemical contributions and the sake's inherent components creates a flavor and aroma profile that is impossible to achieve through traditional brewing methods alone.